Welcome to the 13th century of the medieval ages. I am Floris V, Count of Holland and Zeeland. Currently I am working on a new housing project on the banks of the AMS. For the construction, we are using locally available materials such as timber, adobe, and thatch. These materials are sustainable, readily available, and suited to the local climate and environment. The walls will be made from timber framing and adobe. For the roofs we use thatch, which has great isolation properties.
Good morning. I am Cornelis van Eesteren, Dutch architect and city planner. In the aftermath of war, we sought to rebuild a city that embraced the spirit of modernity. Concrete, our steadfast companion, allowed us to build bold forms. Brick provided warmth and character to our buildings. Steel, our ally in progress, enabled the creation of open, flexible spaces. These materials were our palette, painting a vision of a modern Amsterdam, shaping a city that embraced its bright future.
After the war, a lot of people needed housing, and countries started to build with the materials that were readily available and also cheap. Here behind me you see an example of its time, the beton beard, made completely out of concrete. To help with the housing crisis, the architects were now proposing what became the iconic Dutch row house. These were mainly built from concrete, bricks, and synthetic insulation.
These houses were great at solving the housing crisis, but were not really that sustainable. The materials used for constructing these houses have big consequences in our climate. The built environment is causing 38% of the Dutch national carbon emissions. 11 is emitted during the construction and 27 during the operation of the building. It also contributes to the exploitation of non-renewable resources like the sand used for concrete and construction waste.
Materials like steel and concrete are still strongly embedded in the Dutch construction system. For example, the state subsidizes these materials to keep them profitable. Behind me, you see examples of conventional construction built in the recent years. Fortunately, there are also good examples in the modern construction industry. Behind me is a house called Timber House. In only 6 months, it was constructed using prefabricated timber modules. And what this means is that the current construction industry is changing.
It's transforming to a more bio-based and sustainable way of building. But at the moment, it's all happening at a very small scale.
So the question is, how do we scale up the adoption of bio-based materials on the Dutch market?
Also the materials need to get to know each other. That's why this pavilion is useful. So we have all nice materials that function on their own, and now we put them together, and all of a sudden the behavior is different, even of the individual ones.
Bio-based materials need to become more competitive to be adopted on a larger scale. But how do we do that? Bio-based pioneers are innovating and pushing hard to make their materials enter the traditional market. There are several challenges that slow down and hinder this process. Their main issue is that getting certifications for new bio-based materials is expensive, and there is no guarantee to get it at first attempt. In addition, to get BRL certification, a material needs to be approved by a board mainly consisting of companies producing conventional materials who might have little interest in supporting the bio-based transition. There is also a knowledge gap between science and practice. Although the research on properties of bio-based materials is still ongoing, there is a poor link between what's already known and the conventional market. This leads to opinions based on prejudice or outdated information. Like all new things, bio-based materials are produced on a small scale. Their production costs are higher, and together with added risk premiums, the market price becomes unattractive to an industry that is tuned to good costs. A potential solution to this is combining multiple bio-based materials from different producers into one modular wall system. This way, certifications could be obtained for a system, and material producers could share the costs. This would reduce the entry barrier for new materials and leave more funds for production and scaling. Such a system could also fix the issues of compatibility between the different layers and aid in knowledge exchange. To better shape this preliminary idea, we organized a co-creation session with architects, construction experts, and material producers. The first part of the session was dedicated to the practical design of the module.
Use like very loose materials as this, then you need to close it up.
If you make a villa, just 1 floor, you need a crane.
Questions like the change in the design process, desired flexibilities, size, and the layers that should be included were discussed.
Like how does that light go from that switch to that?
So you don't repeat the elements.
In the second part, we looked into the business setup that will design and manufacture the modular wall system. The experts brainstormed about the business flowchart, structure, and financial matters.
Once you start making this, you learn. Like you now make this thing, now you understand what's difficult, what can be easier. Okay, immediately you do it again.
Our prototype consists of a wall module that offers 90 minutes of fire resistance. It is built with a timber-framed core and filled with bio-based insulation. On the exterior and interior, it is completed with sheets of bio-based materials. It is customizable through the addition of extra cladding or finishing, allowing different combinations of materials. This high degree of flexibility is essential to involve a large group of bio-based material producers in the long term. To fit different architectural and structural needs, the module has a variety of typologies, such as walls, lintels, sills, and columns. These are further customized to fit the desired building structure. The modular wall systems will be designed, developed, prefabricated, and tested by a consortium of bio-based material producers. They form the board of directors, while a dedicated team takes care of the whole process, from communication, design, engineering, assembly, sales, and financial operations, ensuring its quality, the continuous development, and scalability. This business model allows to keep the added value of making a prefab system with the pioneer bio-based suppliers, and goes one step further by showing what designs are possible when you build bio-based.